Hi everyone and welcome. I'm really excited for today's live stream. We'll be hearing from Adam Davis about his and his team's work on the amazing Netflix show Nimona. Some of you may be familiar with Adam from our Learn platform, where you can find everything you need to skill up in Katana, where he's done a fantastic job explaining some of the more technical parts of Katana. You can find the link for both the main site and Adam's specific videos in the chat. But don't go watching those now, it's time for our very first Katana YouTube Live. So thanks for joining us on this historic date. If you want more in the future, make sure to comment, like, subscribe. You know the drill. So welcome, Adam. Before we jump right into your presentation, why don't you tell us a little about yourself?
Well, hi Gary, and thanks for having me. I feel very privileged to be at part of the first Katana Live. My name is Adam Davis, and I'm the Lighting Technical Supervisor at DNEG Animation, and I've been at DNEG for about 4 years now.
Great. So now we're going to show a pre-recording of the presentation while we join you in the chat, and then we'll have a live Q&A with Adam at the end. So stay tuned.
Hello everyone. My name is Adam Davis, and I am the Lighting Technical Supervisor at DNEG Animation. I have been at DNEG for over 4 years now, and I've been using Katana at various studios for about 10 years. Today we'll be looking at how we use Katana for Nimona, and at the end we'll have a quick look at what is in development for our current shows. Let's start by looking at a brief history of DNEG Animation. So we'd finished our first film, Ron's Gone Wrong, which had a long development time and a generous 19 months of shot lighting, so we could establish our feature animation pipeline. We were in shot lighting for Intergalactic and Under the Boardwalk. Intergalactic was a fairly straightforward production for lighting, and therefore only needed 14 months for shot lighting. Under the Boardwalk, however, was more complex and needed more like 17 months. Nimona then came along and had a more compressed timeline of 12 months in lighting and was a much more complex show to work on. As I'm sure everyone knows, we had taken over Nimona from Blue Sky Studios, who had done a truly wonderful job on Nimona already, but we pretty much had to start again as our pipelines were so different. So you can see here we had a very compressed schedule of about 18 months from build to final delivery, with lighting starting in January 2022 and wrapping in Christmas 2022, so not even really 12 months. So let's see what some of the challenges were we had to face for the film. Firstly, we had a main character who could shapeshift. So you can see in this GIF here, we've got a gorilla that turns into a cat, then turns into a rat. And Nimona does this in quite a lot of shots. So we'd have to have lots of different passes for the different characters. And if you look carefully, you might see that when the rat's spinning around, there's actually more than one rat there for the motion blur. So we also have the complexity of all of these having fur as well. We have a huge futuristic city with holograms and screens everywhere, as well as flying cars and stuff. This is a non-photorealistic film with a graphical look, which required a lot of compositing work and a lot of AOVs and extra passes to get the look. There is lots of destruction throughout the film. Nimona likes mayhem, so we have to work a lot with effects and trying to work out how we're going to render all of these different effects and try to get the stylized look on top of it as well. And this totaled 1,400 shots, so that's a lot of shots to get through. So how are we going to do this? We needed to come up with a very streamlined workflow that would allow for multiple users to work on an entire sequence at the same time. So I came up with one template to rule them all, and in the lighting department bind them. Let's have a look at it. So the artist would bring in the lighting template from the shelf tools here. It's called a dynamic template, and it brings you up this UI here, so you can choose some options. Essentially, most of the template is a set of live groups, and our groups get published into our database, which means they can be version controlled and we can actually go and approve our live groups as well. So what we would normally do is have it so that the artist would work with approved live groups, but if there's anything they wanted to test out, they could instead in here choose it to be latest, and they'll pull in the latest live group and they can test it and let me know that it's working, and then we can approve it. As well as being able to set the live group options, there are some configurations options here. So you can have it so it automatically load in bookmarks that the show has published or your own user preferences, as well as filters. So you can have the show filters. So if the show thinks that it would be a good idea to always sort of start off with 50% resolution or no motion blur, those kind of things, these would automatically be added into your interactive render filters, or you could just use your own user ones as well. And once you're happy with your options, you can hit OK and it will load in the template. And as you can see, it's quite deceptively simple. So we're just going to walk through it and you'll hopefully be able to see the power of how it works. So on the right hand side here, we have those interactive render filters. So we've got one that's from the library, and then you can also have show ones. And the top here, this is where we would build our scene. So this is the Importomatic node. And we have two ways basically of bringing things in. We can either build them so we're going through and get the latest packages and put it all together, or we have a QC department which is called Sweatbox, and they can run a QC, and if it's happy they can approve it, and then we'd pull in the Importomatic that was used in that Sweatbox into our scenes. And we also have a test camera as well, so you can just render from a different angle if you need to. Next we have everything to set up the entire show. So we have a library settings live group, and this will be used throughout all the shows. It pulls in exactly the same live group. And this is where I would work mainly. So this is where I would put in any fixes or setups that need to be done across all shows. Then we've got a show settings live group. So this is where the lighting supervisor would work, or myself, and you can set up all the different pass names, or you can have fixes that are for an entire show, or setups for what AOVs are needed for what passes, those kind of things. And then again here we've got something for the Sweatbox team. So if there is any fixes that are needed, this live group is shared between the Sweatbox template and the lighting template, and the Sweatbox team can put in their fixes there and we'd automatically pick them up. Next we have the sequence settings live group. So this is where the sequence lead would work. They'll put in all the lighting that is needed for that sequence, any setups that are needed for it, and then the shot lighting artist can then inherit that from the sequence lead and then add in any changes they want to do for their shots. Now inside this shot group setup group node is a set of live groups. So we've got 10 different live groups, and you can see right now they're all deactivated. And what would happen is you can assign a shot to a shot group, and we've got 10 different options. So you've got shot group 0 to 9, and that means you can say, for example, shots 10, 20, 30 are all looking at the same angle. I'll group those together and I'll put my changes to the sequence lighting in that shot group, and then I'll say, like, 40, 50, 60, they're in another part of the scene or at a different angle, and we'll group those together and we'll put those into lighting shot group 1. And we'll go through a little bit of how this actually works a little bit later. And right now all of these live groups are pointing to a pass-through live group, which I've called blank group. So this allows all these live groups to just flow through. So you can always have it so you've got an empty live group that doesn't do anything. And then finally here we've got a shot settings live group, and that is for you to be able to put in any specific fixes that you want for your shot. So you can group a bunch of shots together, but then one shot might need a slight tweak, so you can just add that there. And then finally you've got your render path set up. So on the right hand side here we've got this render all. That means you can just render everything that's coming into your scene all together. And then on the left hand side we've got this render layer spawner node. So what that will do is actually go through and spawn all the passes that have been created in all those live groups, and we'll go through that a little bit later. And that's essentially it for the template. Now, the power about this is that what happens is you set your graph state variable for your shot, and then it will automatically load in that live group based on the shot. So be like, oh, you're working on this shot, which is in this sequence, so I'll bring in the sequence live group if it exists. I'll bring in the shot groups, live groups that exist, and I'll bring in the shot live group that exists. And then you can change to a completely different shot and it will load in all of those shot groups. So you only ever actually will have to work in one file. It's not even really a file, it's just all these live groups all together. And that means for me, if I wanted to troubleshoot something, all I need to do is bring in the template, set it to a particular shot, and I'll have all of the things from all the different users that have been working on that shot. Okay, let's have a look at this in action for the auto loading of the live groups. So currently right now, I don't have anything set. So this is an empty live group and it tells you this live group needs to be created. So if you were the sequence lead, you'd have to create that live group from the tool shelf. But if you were to set your shot, then it would see that there is a sequence settings live group set up and load it in. So we'll demonstrate that now. So it's currently red, meaning there's nothing being loaded in. I'll go to the shot viewer tab, which is a DNEG tab that we've built that will add in all of the shots here that are for that show. And we generally group everything by sequences. So here I am in sequence H2280 and I've selected shots 90 and 100. What we can do is right click and we can add these shots and it'll automatically add it to our graph state variables. And now you can see it's turned green, and what it's done is it's loaded the sequence settings live group for H2280 sequence. And if we have a look inside this, what we would generally do is have a template for each of these different live groups that gets loaded in. And this means that everything kind of look familiar, whatever sequence you're in, you'll be like, oh, okay, so I'm in this sequence and this is how it's set up, and this is where the sequence lighting will be changed. This is where look dev overrides will be changed, etc. So it makes it very clear, no matter which artist is working on what, because often artists kind of have to move between different shots all the time, and it should look familiar no matter what sequence they're working on. And then we've now got our shot group set up. So we're currently in shot 100, and that's associated with the shot group 0. So I'm expanding out this shot viewer, and now we can see the tag. So this has got a tag of light shot group 0. So this tagging system is something that goes into our database. And then if we have a look, we can see shot 90 is shot group 1. So what it means is if we were to switch our graph state variable here, it should automatically load in shot group 1 and turn off shot group 0. So let's see that. I'm just going to go through and update. So that's turned off and this is turned on. And then it'll also load in the shot live group as well. So everything is sort of dynamically changing in here. It's not a static template, which makes it very powerful. And then based on all of these live groups, that defines what our passes will be, and then you would just spawn them out whenever you change anything. Okay. So let's have a look at a shot group example. So I'm currently working in this shot here, and it doesn't have any shot group set up, they're all empty. So what I want to do first of all is associate my shot with a shot group. So again, I'm going to go over to my shot viewer node, and I'm going to select my shot, this 92010, and then what I can do is say edit tags, and it's going to bring a pop-up here and give all the tags for the entire show. And then there's one here for the shot group 0, and I'm going to tick this and save changes. Now what this is going to do is just mean that that live group is going to turn on whenever that shot group is matched. But you'd also have to set up this live group. So right now I'm saying this is a blank shot group that's been loaded in from the library. we need to now activate this to say we want to use it for this particular sequence. So we go up to the tool shelf for the live group, and we can basically publish in an initial version. So what this will do is start off with your version 1, and you'll go into the database and see if there is a template for the show for shot groups, and automatically load that into the live group. So we'll see that in action. So we're doing our initial setup, and it's going to run that, bring in the template. So this is a template here, and then it's just going to publish out that first version. It just takes a little second. So we've got version 1, and this is just sort of an empty template for you to work off of, just so you have that same structure every time. And now you can right click on this and say edit contents, and dive in and make a change. So we're inheriting this gaffer here, all these lights from the sequence. And what we'd want to do is just change some of these lights. So let's say, for example, we want to change the environment. I'm just going to set the route here to the environment and just show the incoming scene. And I want to change this orange ceiling light here. So I'm going to adopt this for editing by right clicking on it and say adopt for editing. And then I can make a change. So I'll just change the pivot point to Nimona here, and I'm just going to rotate it around a bit just to do something. And once I'm happy with my changes, I can then publish my live group. So I can select this and I can publish it through the shelf tool. So I'm going to just say publish and approve it, and I can give this a comment now. So this is going to go to version 2. So the version 1 was the initial setup. Version 2, I can say that I've rotated the ceiling light. This is good because it basically gives us a version history of all of these different live groups, so it's very easy to see what's changed. So now you can see we've got our sequence settings live group where the ceiling light is at the top, and then we make our change and it's rotated around. And again, we can also change it at the shot level as well if we needed to. Now, we've got all of these different sort of modular live groups, but how can we say, for example, send information down from the top? So say, for example, if I had some settings I wanted to set up for a particular show, let's say the render quality, how could I give the users further below the options to say, oh, you know, this is what preview quality should be, this is what medium quality should be, this is what final quality should be, and then pick it. So what I thought was we could use variables again. So I've got a really simple scene here where I've got a variable switch node, and the variable name is geo, and we've got these 3 different patterns of cube, sphere and plane, and each of these are selecting a cube, a sphere or a plane. And by default, when you have a variable switch node, it's going to load in the first branch, which is our cube. And what we can do is we can set the variable, so we can use a variable set node and say the variable name of geo and make it sphere, and now it's changing to a sphere in our viewer. But what happens if we use another variable set node and we set it to a plane? Well, nothing happens, because what happens when you set a variable is it bubbles up. So I've set it to plane here, then it gets set to a sphere, and then it goes up and up and up and switches it to a sphere. So if I turn off this variable set node of a sphere, we'll now get it to be a plane. But this is not what I want. So say, for example, I set at the top here my quality settings of low, medium and high, and then the sequence lead says, oh, for the sequence now we've got to the point where we want to set everything to medium quality, but then a shot artist has got to the point where their particular shot is at final quality. We want them to be able to override the medium quality from the sequence to their shot to be final quality. So what I did was I wrote my own variable set node, so a variable set DNEG node, and this does exactly the same thing as the variable set node, except what it will say is if the variable is already set, don't override it. So now I set it to a sphere, and then I can change it to a plane and it changes it. So this is pretty cool. The only thing is though that the artist would have to know the name of the variable and the options that they're allowed to change it to. and you don't want them to kind of like dive into live groups and try and figure out what switches are available. So I built a super tool, which is this variable manager here on the right. And all this does is go up your scene and find out all the variable switches that are connected. And then it will look in those variable switches to find out what the variable name is and its options. So here's a very straightforward one where it's going to see that there's a geo variable and there's all the options, and I can just easily switch between them. And then what we can do is we can have a look and see what it looks like in the Nimona template. So I'm dropping a variable manager node at the end of the template, and what it will do is it will group all of the variable switches with the live group that it's coming from. So you can see, oh, you know, in the show settings we've got all of these options, and from the library we've got these options, etc. And then at the top you can kind of search and find out all the different variables. So as I was talking before about render quality, there is actually a render quality option. So I can search for that. I can search for quality, and then it will filter out the list, and we go, oh, there's my render quality. It's currently a preview. I would like to switch it, and then you've got all your options. And you can see here we've got an insane one. So sometimes we had to crank up the values to get clean renders for Nimona. But that's all good, and that means that we can set these up per show and have different setups for the artist to choose from. Let's now take a look at how we actually achieved the look of the characters. So we'd render out two different passes. We would have a diffuse shadow tone pass, which is our main pass, and we'd also have the specular pass from that. And then we'd render out a secondary pass called a key map pass. And this is where you would take your key lighting. So I built a tool that would find anything that was tagged a specific name, which would be your key light. So it could be anything, but it was normally called key, and extract those lights out and render them a secondary pass with a very strong shadow terminator. And we just get this black and white image. And then it would give you all of the lighting information as metadata. And what we would do is we'd combine the raw key map pass with the albedo texture and the metadata that we send about the lights to get the final look of that pass, and we would add it onto with the specular and diffuse. Now with the specular, what we would do is we would extract out that specular and run it through a crypto matte filter. So we had these special crypto mattes that were based on painted global mattes. So you could have each of these individual pieces of geometry a separate crypto matte color. And then what you could do is say average out all of the values that come in onto this piece of geometry. So if you look at the final result, you can see the difference. So first of all, look at the lighting from the raw beauty compared to when we have the final result where we add in this key matte, so we get that really sort of strong line. And secondary, look at the specular on the armor. So on the original raw, it has, you know, that sort of physically based roll off, and then you can see the much more faceted look on the final result. So what we'd need to do is have a way of easily being able to set these up for every character. So we want to make sure that we always get this raw key map that is set up each time, and we also want to make sure that we get the right AOV, so we get these special crypto mats that are rendered out if you're rendering a character, and we want to make sure we have all of the other AOVs that we need. And this is an example here where you can see all this special crypto mat that we would use for all of the individual pieces of the armor, and we'd have the original specular render from the render man, you know, physically based shading, and then the comp treatment where we'd flatten out all these values. So let's look at pass generation. So how we can make it easy for us to be able to create all of these different AOVs, these different passes. So make sure that every character gets this special key map pass or any other passes add-ons that they need. So if we look here, I'm at the library live group settings, and there's no passes that are being defined in our scene graph. And now I'm at the show settings live group, and we start getting these render layers. Now what we do is we add layers as part of the scene graph in a hierarchy. So we start off at the top level, would be grouping them as like prop, character, vehicle, environment, that kind of thing. And then inside each of those categories, we would then add in subcategories. So we'd say for the character, we could add in all the different Nimonas. So we've got regular Nimona, and Nimona as a cat, bear, dragon, etc. The director, golden loin. Now on each of these scene graph locations, we'd use attributes to describe how that render layer should be rendered out. So you can sort of check its order, so you can use its ordering to say if it should be matte or invisible. You can set any add-on passes on that render layer, so all of these extra key map passes we can add as attributes. We can set up all sorts of different attributes to define how that render layer should be set up. And you can keep adding to this or tweaking the attributes on these different render layers throughout. So when you get to the sequence one, more passes are created, and then you can change their definitions, in your shot groups, your shots. And then once you're all happy, you can spawn these all out. So you click this button and it starts creating all these nodes. And what it will do is it will start off first by creating the main pass. So what you'd kind of consider as like the beauty pass. And then it will afterwards go through and create all of the add-on passes. So these key map passes, or for any of the Nimona characters where they've got fur, we would split out the fur pass as well, so we could treat it in comp. And as you can imagine, if you were to create all of these different passes by hand, it would take a very long time, and it's very prone to error. So by having these always defined, we'll know that every time it will be called exactly the same thing. So it'll be called character Nimona, all lowercase, everything will be named exactly as we expect. And what that means is it will make us very easy to be able to then have nuke templates built around these, because we know exactly the names that they're going to be. Okay, this is going to go through and create 67 passes that are needed for this sequence. And this is fairly typical for Nimona, because we need all of these different passes for each character, and because Nimona changes into a lot of different characters, quite often we would have several passes we need to render out. Okay, and it's almost finished now, just doing the last few. And then what we can do is we can have a quick look at what happens when these passes are getting set up. So here we have, an atmos, glass, we've got environment. So even with the environment, we've split out the key map. And we've got our effects here. So we've got all these different effects that are being rendered out. And again, we've got our vehicle that's got the key map pass. And then all of these red ones are all characters. For example, here we've got Nimona and her key map, and Blackheart, and Golden Loin, and there's the director. Now with the director, she would always get an extra pass, which is a wimple. It's because she has this semi-transparent wimple that she wears over her face, and we wanted to have control of that in comp. And then, for example, if we go over to one of the Nimona animals, so we've got the dragon here, and we have a key map pass, and because we've set it up for all of the animals that they would get this extra no fur data as well, so that allows us to treat the fur separately in comp. And if we just quickly have a look, so we have our sort of main Nimona dragon pass here coming down, then it splits off. So what we can do is we can set a graph state variable at this point to say this is Nimona dragon. So if we just quickly go inside this node, one of the things it's doing is when it configures it is it sets this variable. So we see here, and what it'll do is it'll set the name of it to be render layer, but it'll give it the value as the entire path. So root render layers, character Nimona, animal, dragon. Now by having the entire path, that means that we can use wildcards when we use graph variable enabled group nodes. We can say, anything that starts with root render layers character will be activated. So for all the different passes that the character passes, they will get the same thing that we turn on. So it could be the same AOVs, etc. Now, as well as defining a graph state variable at this point, we can also do it further down here. So this is our main beauty pass, and we can set this as a post configure. So it's got exactly the same value for the variable, but we've added post configure here. So that means again that when we're using the variable enabled group nodes, we can activate it only specifically for the beauty pass. So if we can say root render layers star post configure, that means every single beauty pass will get this. You can say every beauty pass gets crypto mats turned on, for example. Or we can say root render layers character, the beauty pass will get the special armor crypto mats, the glints that we were using, and I'll show you that in a second. And then for the add-on passes, we'll also set a couple of variables that lets me know this is an add-on pass and its name is keymat. Okay, so currently we're viewing the sequence settings node, and if we go inside the show settings, we've got something that's setting up some of this render layer stuff. And we can see here that there is this crypto mat. And this is just a variable enabled group node, and it's currently deactivated, and it's looking for the pattern of root render layers star post configure. So any pass that it's its main beauty pass, this will activate for and turn on crypto mats. And then here's our special armor crypto glints that we're going to render out for the characters. And what I've done for this is I've done a little bit of a sneaky pattern. So I'm saying that anything that is of regex match of root render layers character star post configure, so any of the main passes for any character will get this activated, or if you happen to turn on a variable called crypto glint. So crypto glint equals on. If we're just going to show you the rest of that. There you go. So I think there's a flexibility as well that any artist could then activate the crypto glints for any pass by just setting that variable. So that means that, you know, there were times where we had armor type things that were on props or in the environment, and we would want to activate this crypto glint specifically for that pass. So it gives us a lot of flexibility, and it means a lot of things are predefined for us. And that just means that everything gets very consistent. It means that we know exactly the AOVs. We render the minimum amount of AOVs that we need for each of these passes. We can go back and forth with comp. And you can see here now that I'm with Nimona, the main beauty pass, it's activated those graph state variable enabled groups. But then when I go to the keymat pass, these aren't active. Something else would be activating some other variable enabled group specifically for setting up the keymat pass. Okay, so that gives you a pretty good overview of how we're really able to control everything that happens in our template, how it's easy for us to define passes, how it's easy for us to have multiple users working on the same shot. Let's have a look now at light in a city. So we have this city with, you know, we've got vehicles, like flying vehicles with lights on, headlights. We've got buildings with various windows and things. And what we wanted to do is have a way of being able to generate lots of lights. RenderMan comes with something that is called a light array. And a light array means that you give it a light and you give it a whole bunch of matrix transforms, and it will populate that light onto all of those transforms. So you can have thousands and thousands of lights that are using the same material, and it can just be any kind of light, like a sphere light or a rect light, and it'll be extremely optimized because it's just using that one material once across all of those lights. So what I want to do is build a tool that you would feed it some information and it will generate lights off of that information. So I've got a fairly simple scene here where I've got 2 teapots and a donut. And what I want to do is add lights to these geometry. So the first thing I've done is created some lights. So I've got, like a rect light, sphere light, disk light for some examples. And this is the tool that I've made called the light array generator. And what you do is you'd give it some light locations, and when you give it their location, it will turn it from a regular light to a light array. And then what you can do is you can give it some geometry locations and start generating lights on them based on that geometry. So here I've got my rect light, and it's changed to a light array. And I'm going to give it the teapot 1 geometry. And what it was doing under the hood is adding all of this instance matrix information. So you can see now that there's 66,000 entries for this instance matrix. Doesn't see anything in the viewer, but if I were to render it out, you'll be able to see that it's now got thousands of lights that's been added. And what it's done is it's added it to every point. So this choose light array creation method, you can choose to add it to points or faces or bounds or to locators, all that kind of stuff. Currently it's just set to points, so every single one of the points on this teapot has now got a light, and I'll render it out. And you can see that. But this is not particularly handy for a lighting artist to know what is going on. So what we want to do is visualize these lights. So at the bottom of here, I've added a display option of visual, and now that's going to create an instance underneath this light rig option, so you can at least see all these lights that are being generated. The first thing you might notice is that all the lights are all pointing the same way. So let's see if we can fix that. So what we can do is set it so that the lights use the normal on the geometry instead. So I've got an option here that says use normal, and if I say yes, it's now going to complain. It says there's actually no normals that are on that geometry, and if that's the case, you can actually generate your normals, and this will go through and calculate the normals instead of using the normals that are on the geometry. And there you go, you've now got tons and tons of lights that are being created on this geometry. And I'm going to kick off a live render just so you can see that. So what's happening is it's creating all these individual lights, but when it goes to the renderer, it's going to delete all those individual lights and still use the light array. So you've still got that speed up of using light arrays instead of individual lights. And we've got some more controls here as well. So we can change some of these methods. We can add in a second light. So if we add in a sphere light, what we'll do is it will just alternate between a rect light or a sphere light, so that you can have some interesting results doing that. And we can add in another piece of geometry, so we're just going to add in another teapot, and now we're generating a bunch of lights on that second one as well. And we can alter the percentage, so right now it's generating 100% of the light, so every point will get a light, but we can set it to 30%, for example. And what we can also do is use cell statements, and we can say get everything under root world geo, and we can bake that out. So it makes it a lot easier for kind of selecting all of the geometry you want to add lights to. So what we can also do is randomize it. So right now it's the same. So you can see from my render, the lights are in the same place in the teapot. That might be something you want to have. And I've also added it so that it's randomly given it color, but the same color is for each of the teapots. And this might be the look that you want to have, where they're all exactly the same, but they have like random positions. Or we can change it to percentage random per path, and now it's going to be different for these different teapots. And then you have a percentage seed, so you can change that seed and it will randomly generate it again. And you could always do something where you say animate this percentage seed and get something really funky, you know, maybe like a disco sort of effect. So what we can do is also change this. So instead of the distribution being even, or the method being cycle through, we can change these. So if we change it from cycle through to duplicate, what we'll do, instead of being alternating those lights, we'll have the same light. So the sphere light and the rect light on that same point. And this might be a good if you wanted to have a specific look. Say, for example, you're trying to get something for headlights and you wanted to have two different cone angle lights that are going on there. You could add the two lights and we'll add them both to those points. And we can also change it. Instead of being even, we can weight it. So we can, you know, say 20% of the rect lights and, you know, 80% sphere lights, or here changing it to 10% rect lights and 90% sphere lights. You've got a real way of customizing this look. I'm going to change it now to faces instead of points. There you go. So now we've got a light on each of these faces. And what we can also do as well, if I just remove the torus, is, let's say, for example, instead of having it so we've got a percentage of the geometry is going to get lights, what about if we wanted to specify the exact faces that we want? Well, we can do that as well. Let's make it so that only the spout gets lights. I can use a face set create node just so I can get the numbers for all of the faces, and I select my teapot and I can go into face selection, select my faces. So let's just grab all these on the spout, and I'm going to add that in, and I can just get this list now and add it into my tool. So we can change it to use list, and then I can plug in my numbers, and it's just going to add lights on our spout. That's pretty cool. So if we had lots of teapots, we could then generate the same lights on all the spouts using this. So another thing we can do as well is that we can translate along the normal, so we can, you know, push it out, that kind of thing. So you might not want to have the light exactly on the geometry, you might want to move it out. So again, let's think of like a headlight. You might want to have it so that you push it out in front of the glass maybe, or you might want to have it in between the glass and the bulb, that kind of stuff. That gives you a lot of flexibility. So as I said, we use this tool quite a lot in Nimona for the city, and this is a kind of idea of where we could really sort of randomize the number of lights they're on and randomize their you know, intensity, slightly change their color. Now we did something a little bit different for when the buildings were instanced. So instead of setting it up so that the lights were generated through that tool, what we would do is instead we would look at the instance and we'd give it an ID, and we'd pass that to the material source, and we'd use that to add variation to it. So finally, let's talk about the future, my evil plans. So we started to experiment on Nimona with Nuke Bridge to enable us to do the compositing. So you saw earlier on how we had the main pass and the key map pass, and the key map pass was just a black and white image, and then it would go through comp to multiply it by the albedo that's coming from the main pass and adjust it, etc. Now, the lighting artist would not be able to know what that's going to look like until it got into comp. So one of the things they might do is render, you know, like a first middle pass, get that into comp, and then make sure it looks right. But what I thought was that we could start trying to use Nuke Bridge. So I started experimenting with it on Nimona, and we're sort of using this quite a lot now on our current shows. So what I've done here is I've kicked off a live render, and this is of our key map pass, and I'm rotating the light that's called key that's filtering into our key map pass. And then what it'll do is it will go through Nuke Bridge. So I've given it a Nuke template, and it tells you how to take these two different passes and combine them together to get this final result. And that means I can tweak the lighting and see the key map pass, but also see the end result you'd get from Nuke. So this, obviously, when you're working on shows that have quite a sort of heavy compositing element, which for us is happening more and more. There's a lot more shows that seem to be more of a non-physically based show. You want to really kind of know what your end result's going to be. So being able to get this immediate feedback has made it a lot easier for us. But what I thought though is I could take this a little bit further. So rather than just being able to apply nuke looks and stuff like that, what I thought was what we could do is have a way to have them talk to each other back and forth. So what would often happen as well is you would render out your passes, take it into Nuke, and then use that to balance your lighting out. So if you've got your lights in the right position, but you're not sure, you know, like how much of the key light should be done versus the fill and their colors and stuff, you can do all of that in Nuke, and then you'd be like, okay, I've done that all in Nuke, but now I need to have it back in Katana. I'll like manually try and recreate it in Katana by copying some values over. What I thought would be much better is to again use Nuke Bridge, but previously what we were doing was we were using Nuke Bridge and we were using Nuke headlessly, so it would just send that information to Nuke and bring it back into Katana. But what we can also do is have a interactive Katana Nuke setup here. So what I've done is I've again sort of set up a live render here, and then now it's a live connection to Nuke Bridge, and I've got this node here. So my render is coming in and I've got this adjustment node, and what I can do with this is change either globally the intensity, exposure, saturation, color, shadow color, or per multi-light, so per light group that we're using. And I can also do cool things where I can solo each of the lights, easily see their contribution, and then I can make adjustments and just work, and it's very, very quick. So I'm making these changes here and I automatically see it in Katana and Nuke. And I can kind of go back and forth, so I can kind of adjust things here in Nuke and get them quite nice. But then I could go back into Katana and rotate my light, wait for that to the render to resolve a little bit, and then start working back in Nuke again. And this makes working so much faster. You're not having to wait for the sort of the live render to sort of kick off again and start resolving a bit before you're making a light adjustment. So definitely for things where you need to kind of balance your lights, be able to get your color right, that kind of stuff, using Nuke is way quicker than Katana. But right now this is sort of like a temporary connection, so I'm making all these tweaks in Nuke, but if I was to just close my Nuke now, I'd lose everything that I've got, and I'd go back to the original image. So you can see here we've got our all pass here, and we've got our Nuke Bridge, and it's different. You can see that I'm making changes in Nuke that's changing the lighting, but what I want to do is be able to have this go back. So I don't know if you just saw at the end of here, but what I've done is on this node I've got a copy to clipboard option, and then what I can do is open a tool here that I've got on my Gaffer 3 called the Gaffer Spreadsheet. And what this will do is go through and find all of my light groups in the Gaffer, group them together, and then I can paste my values from Nuke and it will apply it to all these lights. And because this is still a live group, it will just automatically update here. Now I have copied all of my lights here to Katana, and it's running through Nuke Bridge again, so I'm basically doubling up. So I've now got the result in my all pass that I had in Nuke. I now need to basically reset everything in Nuke back to what it was before, so that these two match and I'm not making any changes. And then I could also go back to Nuke again and start tweaking things. So just go back to Nuke and say reset all, and these will now match. We'll now have a Nuke Bridge and all pass that are the same, but I've made my lighting tweaks. So pretty cool. Now you see they're the same now. And finally, another thing that we're working on is, because we have these live groups that are individual modular building blocks, what we can do is essentially say, go ahead, build the scene, you know, get the latest stuffs, pull in all of these live groups that we know should exist, spawn out all of the passes and then put those passes on the farm. So this would mean that you would not even have to open Katana. It would just update everything for you. This will open up a lot of doors in terms of being able to easily update lots of scenes at once without really opening Katana. It means that we can kind of track things outside of Katana for versions, and it could even mean that production people could kick off renders for us without actually opening Katana at all. And that's just something that we're working on at the moment. Okay, I hope you've enjoyed this talk about how we've used Katana in Nimona, and then we can now have some questions.
Amazing. Reminds me again what a great film it is. If you haven't seen it, make sure you head over to Netflix and enjoy. So let's start the Q&A. I'll start with a question from myself. Over to you, Adam. I'd like to ask if you had a favourite or most interesting sequence from the show.
Yeah, I think towards the end of the film, where Nimona turns into the shadow monster and she's destroying the city, there's a really cool sequence where the director's up in a tower and the shot goes flying from the director all the way across the city to Nimona, and you kind of get to see all of the things I talked about all in that one shot. So you've got, you know, effects, destruction, all the lights from the city, everything is all thrown in there at once. So I was really impressed when we managed to get all of that out.
Yeah, I remember the sequence. It was really, really, really fantastic. So we did have a question from Alankran in the chat. I noticed that you've managed to put the answer there, but just for everyone else, if people aren't checking the chat, he was asking about, is the artist able to just populate the pass in the scene as needed, or they would have to load all of them?
Yeah, so originally our thought was that we would define all of the passes in the show settings node, and then you would delete the ones you don't need for your sequence. So that means that you would only work on those ones. And then what you could also do is, for each of your shots on that render layer, specify what shots they are going to be for. So you might be a case of, you know, Nimona's only in shot 10. We don't want to render out for shot 20. So we'll tag that. And then when we go to submit all of our shots, it would only submit the renders for the shots it's listed for. So it means it's like really easy to do that. One thing that we've worked on as well since Nimona is being able to sort of scan your scene. So what you would do is scan your scene and it will see what assets. So it's just like kind of loop through all your shots, see what assets are in all those shots, and then create the render layer based on all the things that it finds.
So dynamic based render layers depending on what's actually the contents of the shot. Yeah, really, really nice. While we wait for see if there's any more questions coming through the chat, one thing that I find with a number of customers is how they iterate their template and how things like progress as they get more and more familiar with Katana. Do you have anything that you would do on the next show that would be different to the way that you did on Nimona that you'd be willing to share with us in terms of like template advancement, or maybe something that you did for the first time on Nimona on the template?
Well, yeah, I mean, that whole like dynamic template was built around the fact that we had so many shows working at the same time. And what I didn't want to have is the fact that like I would look at one show and it'd be a completely different template to another show. And then it just gets really hard to maintain and hard to troubleshoot. So I wanted it to be one template to rule them all. So I set that up for Nimona. Right now, it's sort of still a little bit restricted in the fact that you only have these specific silos that you can put things in. So you've got your library, show, sequence, shot group, and shot live groups, and that's it. One thing that I'm working on now is the idea of being able to specify what live groups you want to build with, so you can have a flexible number. And the idea as well is to be able to render these out outside of Katana. So you would be able to bring in all these live groups, a list, and you could then say like inject another live group at the bottom that you would specify to say turn everything to gray render or something like that. So it gives you the flexibility to kind of inject things wherever you want and then build your render layers.
Really, yeah, sounds really, really cool. I was really excited to see the work that you've done with the Nuke Bridge as well. In terms of if you could put an idea forward to the product team and for the advancement of the product in the Nuke Bridge area, what one thing would make your life a lot easier for DNEG?
Speed. Speed
Yeah.
is always good. When you start getting really complicated scenes, it does have a bit of a hit. So faster would be better. The other thing, I guess, as well, would be just making sure you have support for everything that you could do in Katana as a render. So being able to like crypto mats and stuff like that and be able to pass them out, because a lot of our looks are based around using crypto mats and things.
Yeah, that makes a lot of sense. And do you guys use Deep at all in any of your workflows?
We a bit. So when there's things that are like, you've got volumes and stuff, and you've got stuff that's going to be hard to be able to render with mats and put them back together, then we'll use deeps. Generally speaking, because our shows generate a lot of data as it is, we try and use crypto mats and instead use mats and crypto mats instead of using deep as well.
Cool. As we're getting close on time, it's a really nice question maybe that we can finish with towards the end. I'm not going to try and pronounce how that's supposed to be pronounced, but I will say, what was the most hardest shot you had to work on? And was there anything that got cut due to complexity? Is there anything on the cutting room floor that we didn't have? But also, what was the trickiest shot?
Well, I work on all shots on all shows, so I'm not like an artist who's working on a specific shot. So I would say again, like that sort of end sequence was the trickiest part for us to do for Nimona. It was like the best to do, but it was also really tricky to get it out. So being able to get all of those things, we had like crowds, we had loads of characters with fur and the destruction, everything. Getting all of that to work together was very challenging, but very rewarding.
Cool. Unless we have any last questions, I think it's probably we're reaching the top of the hour. Maybe we can wrap it up. Cool. All right. Well, thank you very much, Adam, for a great presentation and for joining us today. And thank you all for joining us as well. And remember, if you'd like to see more like this, be sure to like, subscribe, and comment. And until next time.